Alright, so 3.1b, and we were talking about the leading term test, which I put there on the screen for you. And it's pretty easy for you to kind of discover. So I'm just going to write one up here, and we'll go through it. Okay, so there's a polynomial function there, and let's look at the leading term. All we're concerned with is this part right there. Alright, so what we're going to do is we are going to discover what this graph is going to look like. Now, these are our four options of what the graph can look like. These little jagged things means we really don't care what goes on here. Remember, I talked to you about end behavior. We're concerned about what happens on both ends of the graph, not what happens in the middle. I don't care what happens in the middle. That's what the little jaggy things with, okay? So, if this number here, or this term, 3x to the fourth, has an even exponent, and the number in front of it is positive, that's why I put a plus there, then the graph will look like that. If this exponent is even and this number here is negative, it's going to be flipped over and open down. So this kind of goes along with the examples I showed you in the last video. If this exponent is an odd number, it's automatically going to make it look like this. If the sign in front here is a plus, it's going to look like this. If it's negative, it's going to be flipped over and look like that. Okay, so that's all that's doing. So if I showed you one like f of x equals x to the fifth plus 1/4 x plus 1, you could go, oh, it's positive and odd. So I look here at positive and odd, and I know it's going to look like that. Alright, so example 1, they give you A, B, C, and D, and then they give you examples, and you're just supposed to match the examples with the A, B, C, and D. And you should be able to do that very easily just holding on to this top of page 258 where I got that information. Okay, so not too terrible. Finding zeros of factored polynomial functions. Alright, so what that means again is basically find the answers of factored polynomial functions. Okay, so let's go ahead and jump into an example here. Function p of x equals x cubed, and again that p of x means nothing. That doesn't matter if it's an f of x or a p of x. As long as this letter and the letters here are the same, which they always will be, we don't care if this is an f, a g, a p, it doesn't matter. Okay, we do everything the exact same. Alright, and it says determine whether each of the numbers, we need to find out if the numbers 2 and -5 are zeros of this equation. So basically what they're doing is they're saying if we put in a 2 and solved it, is it going to give me a true answer? If I put in a -5, is it going to give me a true answer? Now what do I mean when I say true answer? I mean when this is equal to 0. So basically I'm saying, do these numbers work when I plug them in here? Meaning, is the graph of this going to cross at 2 and -5? Which means my y value is going to be 0 if it crosses x at 2 and -5. So I'm going to make that a 0. So that's all I'm going to do. So I'm going to put a 2 cubed plus 2 squared minus 17 times 2 plus 15, and I want it to equal 0. Does it? No, it equals -7. So 2 is not a 0 of p of x. Now I put a p of -5 in. So -5 cubed plus -5 squared minus 17 times -5 plus 15. Does that give me a 0? Yes, it does. So therefore, I know that -5 is a 0 and 2 is not. So we have p of negative 5 works, which means that when we have the graph, and let me put a graph here, we get something like that. So we get it crosses here. 2, it does not cross at 2 because this is, let's see, it says 1, 2, 3, does not cross there. It crosses here and here. So there are 3 answers, but they're asking us, does it cross at these 2 points? Well, this obviously is one of the answers. We don't know what the other 2 answers are. They didn't even give us an option or ask us to do that. They just asked us if these 2 numbers work. Well, one of them does right here, and one of them doesn't right here. It doesn't cross here. Okay, it turns here, but it doesn't cross x there. So that's what they were doing there. So let's look at something here. If I were to factor this into 3 binomials, we're not going to go into how to do that right now. I'm just going to do it for you. Okay, so if we factored it down, what happens is once it's factored down, we can look and see what our zeros are. Our zeros are what makes this 0, makes that 0, what makes that 0. So that these 3 points are where the graph crosses the x-axis. So when we express our polynomial as a product of linear factors, linear meaning the exponent on each one of these variables is 1, we can easily find the zeros by making it equal to 0, by making our y value 0. So there's the 3 places where it crosses the x-axis. So if we were to look at example 3 and write f of x, and I'm just going to give it to you factored, the book does. Oops, that's not a very good x. Okay, so when I look at this, I know that there are 4 answers here, but one of the things you need to look at is these 3 are the exact same value. What's going to make this one 0 is 2, 2, and 2. So even though we get 3 answers, they kind of get crunched together there and basically are just one answer, and we'll get into what that is in a minute. And we can write this then as 5 times x minus 2, the quantity cubed, times x plus 1. Alright, so to solve this, we make this equal to 0, and we use the product of 0 products, meaning that make that equal to 0, so x equals 2, crosses at 2. And we do x plus 1 equals 0, and that makes x equal to negative 1. And those are the 2 places where we cross the x-axis. Okay, so for example 4, that's what they give us. So let's go ahead and put some things together. Get rid of those. Get rid of those. And that equals g of x, or basically 0. And to solve this, we use the product of 0, or the principle of 0 products. So we look at this, x minus 1 equals 0, and x plus 2 equals 0. So x equals 1, or x equals negative 2. Those are the 2 places that we cross the x-axis. Okay, a new word for you, multiplicity. Alright, so what we're going to do is we are going to look at how many times our 0, our root, our answer, appears. Okay, right here, see this has an exponent of 2. So our 1 appears in here, and it also, well, let's look at this one, here and here. So the multiplicity, how many times this is multiplied by that, is 2. So the multiplicity of negative 1, so negative 1 has a multiplicity of 2. The negative 2 here, or I'm sorry, the 1, it's just a 1, not a negative 1. Then the negative 2 right here, how many times does it fit in here? Twice, so the negative 2 has a multiplicity of 2. Okay, so the multiplicity, basically all that means is how many of the same answer do you get? Okay, so this is x minus 1 and it's squared, so the multiplicity is 2. This is x plus 2 and it's squared, so the multiplicity is 2. Okay, so the root or the 0 has a multiplicity of how many times it fits into the factored problem up there. And this is one other thing I want you to look at, middle of page 261, that if we have a factor, so let's say we have this and that. Alright, what that means here is if this exponent is odd, then the graph crosses the x-axis at this point. Okay, at C, or at 3, not negative 3. If this exponent is even, then the graph is tangent to the x-axis at that point, meaning that it may cross at negative 3, but at 2, it may just bump up against the line and go back down. So it's tangent here and crosses there because odd and even. So this is example 5. We're going to go ahead and factor this one down because we can't do anything. So we're going to group these two together and factor out an x squared. And then factor out a 9 here. And again, paying attention to your positives and negatives, because when you distribute this to the x, you get your negative 9x. When you take negative 9 times negative 2, you get a positive 18. So because of this negative, you're going to have to be careful about the sign right there. So just something to pay attention to. Okay, so that's x plus 3 and x minus 3. Alright, so notice here that I factored this down to this. How did I know to keep going? Because earlier I said when we were dealing with multiplicities, we're talking about linear functions. We have to reduce these down into linear function in order to know what not only our multiplicity is, but also where it crosses the x-axis. So make sure your exponents are gone. So you only have an exponent of 1 on your x's there. So once we're down to that, we can look at the let's see, find the zeros. What makes this one 0, this one 0, and this one 0? So negative 3, positive 3, and positive 2 make those 0. So the f of x, when it's equal to 2, we get zeros of 2, negative 3, and positive 3. And that's all they asked for, is what are the zeros. And I knew that I had 3 because of this cubed right there. And I will finish up with example 6 and just a bit more in the next video.